Hello, we've got a brief video summary of some of the stuff we discussed in class. Particularly what we're doing is we're studying average rate of change, specifically the graphical support and the interpretation. So in this particular situation we're studying infection rates of computers in the 1990s, which shows that there was a drop in infection rates for a little while, but then there was a much more rapid increase in computer infection rates in the years following 1993. So these questions are asking us to quantify, or to put into number form, what exactly is happening to the computer infection rate over various periods of time. In the first case, we're asked to find how the infection rate changes from the first to the third year after 1990, in other words, from 91 to 1993. So graphically first, the thing that I need to look at is the change in time and look at the change in infection rates over that period of time. To do so, you just find the first point on the graph, 1, 1, and you go 2 years over and then down to the graph. Then you can label specifically how much has changed in that amount of time. There's 2 years passed, and there was a drop in about, and this is just an estimate anyway, of about 0.8 infections per 1,000 computers per month drop in that 2-year period. So now what we have to do is actually quantify this and put it into the right language. So to do the calculations, simply evaluate the function at 3 and 1, and you get a fraction that reduces. And really, when you see the graph, the way the graph is supporting is it's showing a 0.8 drop in infection rate over 2 years, which equates to, after we divide it out, to a 0.4 drop in infection rate annually. So if it's 0.8 over 2 years, it's logical that it would be a 0.4 drop over 1 year. Now, just saying infections per year doesn't mean you actually understand what happened over that time, and so that's why we need to state a paragraph or a sentence anyway that sort of translates and unpacks what all of this mathy language is supposed to be telling us. So here's how I did it in my words. From 1991 through 1993, infection rates dropped an average of 0.4 infections per 1,000 computers per month. That's a mouthful of stuff in each of the 2 years from 1991 to 1993. And then I also translate that rate, so basically monthly there were 4 fewer computers out of 10,000 monthly that were infected because of the whatever improvements in antivirus software. For the second question, we're asked to study the change from rate of change from 1 to 5. And so the first thing I do is look at the graph and evaluate f of 1 and f of 5, showing a rate of just 0 infections per year. That's a rate of change, so it's basically saying that the rate of change remained constant, unchanged, if you will, over that 4-year span. Now, I'm going to jump ahead to part D because it asks the question, what does the answer imply about computer infection rates, and is that exactly true? The first thing I want to point out is, when I look at the graph, what I see is the infection rate in 1991 was the same as the infection rate in 1995, which again seems to imply there was no change in infection rates unless you look at the entire graph. My calculations also indicate no change in infection rates, but when I look at the graph I see that the 0 infection rates per year is in fact an average. So this horizontal line says there's a net change of 0, however, the infection rates decreased and then increased by the same amount over that time period. So the net infection rate was unchanged, but there was a drop and then an equal rise in infection rate. So here's how I parse that out. The 0 infections per year rate makes it seem like there was no change in infection rates from 1991 to 1996. However, or that should be 1995, sorry. However, in reality, the infection rates decreased and then increased by the same amount over that time period. And let me just change this to a 5 just to make myself feel better. Alright, so to finish off the exercise, and once again to look at how we can graphically support our work, once again, the red line indicates that there should be a decrease in the infection rate and a very small decrease, a relatively insignificant decrease, and that's why I have a small number that's negative. The horizontal line indicates a 0 net change in infection rates, so the average rate of change is 0. And finally, in the last example, from 95 to 98, we can see that over that 3-year span, there was about a 4.2 increase in infection rates. So here's how we can actually look at this work. Again, we have the notation which says what's going on, and the notation says there was a 4.2 increase in the infections over a 3-year span, and when I divide that out, it becomes 1.4 infections per year as a label. Now, just graphically, over a 3-year span, 4.2 is the same as in a 1-year span there being a 1.4 increase. So 1.4 increase over 1 year is the same as a 4.2 increase over 3 years. So this is what the graph is trying to tell me, that when I did my simplification is correct and reasonable because it produces a similar triangle when I work it out against the line. So to translate this one, I already proved here that I understand the meaning of my rate. So all I have to do is make a comparative statement. So here I say the infections rate increase rapidly, relatively quickly. So increase because the graph is going up, relatively quickly because it's much steeper than the decrease that we saw previously. So that's what I do in my statement of understanding. I've already proved I know what the label means, but I'm just trying to talk about the significance of this answer relative to the last two answers that I got. So hopefully that makes sense. Once again, what we're trying to do is include an appropriate label, and that's usually the label, or that it will always, in rate of change, it'll be the label of the y variable against the label of the x variable, so infections per year. Always need a statement of understanding that avoids using the phrase infections per year, but rather unpacks what that actually means. And finally, we need some sort of graphical representation, usually showing the change, and then we can show the reduced triangle if there's room on the graph to do so. Again, hope that helps. Have a great day.